Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation with variable questions. So we are going to solve the given differential equation of order 2 using variation of parameters method. So let's get going. Problem: solve d square plus 1 into y equal to cosecant x by the method of variation of parameters. So we are given a differential equation of order 2. Given differential equation, d square plus 1 into y equal to cosecant x. Consider as equation number 1. Now we need to find the general solution of the given differential equation using y equal to yc plus yb. So firstly we'll find yc using the auxiliary equation and later we'll find yp. The auxiliary equation is f of m equal to 0, where f of m is m square plus 1, right? So we are having f of d equal to d square plus 1. Just replace d differential operator with m, so that we'll get f of m equal to m square plus 1. Now the auxiliary equation becomes m square plus 1 equal to 0. We need to find the roots. So let's take this 1 to RHS. We'll get m square equals to minus 1, then m square equal to, then m equal to plus or minus square root of minus 1, right? Is equals to plus or minus, since we know that square root of minus 1 is I. So we'll replace square root of minus 1 with I. Therefore, m equal to plus or minus I. Complex roots, right? Or the roots are complex conjugate. Right? We know that if m equal to plus or minus, if m equal to a plus or minus ib, then yc will be e power ax into cos bx c1 cos bx, right? c1 cos bx plus c2 sin bx. If a equal to 0, you'll get e power 0 into x, which is e power 0 into c1 cos bx plus c2 sin bx. Since we know that e power 0 equals to 1, then yc becomes 1 into c1 cos bx plus c2 sin bx, right? From this we'll get c1 cos bx plus c2 sin bx. Just compare m equal to plus or minus I with plus or minus ib. Then for b equal to 1, we'll get yc equal to c1 cos 1 into x plus c2 sin 1 into x, right? Therefore yc equal to c1 cos x plus c2 sin x. We got yc. Now we need to find yp, particular integral. So we are having yc equals to c1 cos x plus c2 sin x, right? Just compare it with yc equals to c1u plus c2v, then u equal to cos x, which is a function of x, and v equal to sin x, right? And compare the given differential equation d square plus 1 into y, which is equals to cosecant x, where d square y by dx square plus p of x into dy by dx plus q of x into y equal to r of x from these two, by comparing these two, we'll get r of x equals to cosecant x. Okay. Now let y be equal to a into, we'll just replace c1 and c2 in yp. We'll get, just replace this c1 of yc, then we'll get c1 and c2 of yc, then we'll get a into cos x plus b into sin x. So yp is given by a cos x plus b sin x, or you're having c1u plus c2v, right? Just replace c1 and c2 by a and b, then yp will be au plus bv. Here a and b are functions of x. We'll find a and b later using formulae. Okay. So let p equal to, yp equal to a cos x plus b sin x. Here a and b are functions of x. Okay. Then u equal to cos x, v equal to sin x, and r equal to cosecant x. A and b are given by a equal to integral minus vr by uv1 minus vu1 into dx, and b equal to integral ur by uv1 minus vu1 into dx, right? Here v1 is a derivative of v with respect to x, and u1 is derivative, first derivative of u with respect to x. b1 is first derivative of v with respect to x, and u1 is first derivative of u with respect to x. Okay, so in order to find a and b functions, we'll firstly find uv1 minus vu1. See, these two are in denominator, right? So the denominator, we should remember that the denominator must be non-zero. If it gets 0, the integrand becomes undefined. Okay, fine. Let's now find uv1 minus vu1. I'll find u1 and v1. If u is cos x, then derivative of u with respect to x is u1, right? Derivative of x, or sorry, derivative of cos x with respect to x, which is minus sin x. Likewise, if v is sin x, then derivative of v with respect to x is v1. Derivative of sin x with respect to x is cos x. So v1 is cos x, right? Now coming to uv1 minus vu1, u is cos x into v1 cos x minus v sin x into u1 is minus sin x, which is equals to cos x into cos x is cos square x, minus into minus plus sin x into sin x, sin squared x. Since we know that sin square theta plus cos square theta equal to 1, then we'll get sin square x plus cos square x is 1, which is not equals to 0, non-zero, right? Fine. Now let's find a and b. Let's now find a and b. Firstly, we'll find a, which is given by minus vr by uv1 minus vu1 into dx is equals to integral minus v sin x into r cosecant x by uv1 minus vu1 is 1 into dx, which is equals to minus integral sin x into cosecant x into dx. Since we know that cosecant x is reciprocal of sin x, so let's replace cosecant x with 1 by sin x. Here sin x gets cancelled, this equals to minus integral dx, which is equals to minus integral dx is x, right? Therefore, a equal to minus x, right? B is given by integral ur by uv1 minus vu1 into dx. This equals to u cos x into r cosecant x by uv1 minus vu1 is 1 into dx, which is equals to integral cos x into cosecant x dx. Since we know that cosecant x is reciprocal of sin x, so let's replace cosecant x with 1 by sin x, right? This is equals to integral cos x by sin x into dx. If you know formula of integral cot x, you can just replace cos x by sin x with cot x, okay? Or we know that cot x can be written as cos x by sin x, right? If f of x equals to sin x, then f dash of x will be derivative of sin x with respect to x is cos x. So this is of integral f dash of x by f of x into dx form. We know that integral f dash of x by f of x into dx is log mod f of x. So we'll get log mod sin x or log sin x simply, right? Now I know the formula of cot x dx, right? So I'll just replace cos x by sin x with cot x. So I'll get integral cot x here, which is equals to log sin x. Firstly I'll write log mod sin x, and then we can write this as log sin x. So we got b again, b equal to, therefore b equal to log sin x. Also we got a, we are having a and b. Let's now write yp. Now yp equal to a cos x plus b sin x, right? Is equals to a minus x into cos x plus b log sin x into sin x. We can write this as minus cos x plus sin log sin x, log sin x. Or you can just write log mod sin x, okay? That's not an issue. Now we are having yp, also yc. Let's now write the general solution. The general solution is given by y equal to yc plus yp, then y equal to yc c1 cos x plus c2 sin x, yp plus yp is minus x cos x plus sin x log mod sin x. This completes the problem. So we have seen a problem from variation of parameters in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.